Okay, this question said a sample of argon gas at STP occupies 56.2 liters. Determine the number of moles of argon. So this question is asking me to determine number of moles. So that means that I need to use ideal gas law. So ideal gas law is PV equals nRT. Okay. So the question also says STP. So I need to remember that STP means my temperature is 273 degrees Kelvin and my pressure is 1 atmosphere. Okay, you need to remember that if you don't know it already. So I'm determining the number of moles of argon, which means I need to isolate the variable N in ideal gas law. And I do that by doing some simple algebra of moving RT over to the other side. Okay, I'm just going to clean this up. Okay, so it's PV divided by RT equals N. So step 2 is I look to see if there's any conversions, and there's none because I'm given volume as liters, and that's the unit we want. And then of course STP is in our units of Kelvin and atmospheres. So I'm actually already ready to plug it in. So my pressure was STP for 1 atmosphere. My volume was given as 56.2 divided by R, which we also need to remember that our R constant is always going to be 0.0821 with a bunch of units behind it. And then my temperature was 273 Kelvin. So now I'm going to plug this into my calculator. Hold up, I got one of those old calculators. 2.5. So number of moles, 2.5 moles. Okay, so there's also another explanation for all this that I'd like to share with you. There's another way you can do it. This is the more advanced way. So if you have a really good understanding of what we've been doing in chemistry, then you're going to get this explanation as well. So if a sample of argon is at STP, then that means that we can expect 1 mole of the gas to equal 22.4 liters. So you have to remember that this is Avogadro's law, that 1 mole of any gas is going to be take up a volume of 22.4 liters. So if argon is 56.2 liters, then it's 22.4 divided by 22.4 liters. That will tell you the number of moles. So when I actually do that in my calculator, just to double check, that gives me the same answer, 2.5 moles. So you could have also done it that way. Either way is acceptable, just as long as I get work shown.